even if you knew everything Tesla was doing, even if they published the source code, a competitor's got to build a fleet of vehicles. They got to get them out there. They got to run them for years because they got to turn the data engine crank to get the thing going. And then at the end of that, then they get results. The the fleet is a search engine. It's not a tape recorder.
Just a few weeks ago, Elon Musk did something extremely gutsy. He did a live stream where he and his director of autopilot, Ashok Elaswamy, did an impromptu test of full self-driving version 12 on the streets of Palo Alto, California. For 45 minutes, the car drove itself from random pin drop locations and to Mark Zuckerberg's house and then back again to Tesla's headquarters. In that time, the car drove flawlessly, except for one intervention. Today, we have James Douma, an expert in machine learning and a regular with the Tesla community. He's here with us to break down why this seemingly simple drive is so historic. What exactly does Tesla mean when they say that the vast majority of version 12 is AI coded? Can competitors simply copy the software? How many years will it take for the next robotaxi company to emerge? Thank you again, James. I really appreciate when you come and join us. This has been long overdue. We've got so many people that's been clamoring to hear your take on what happened on that version 12. So thank you, James. I appreciate you joining.
Pleasure to be back. Thanks for having me.
I'm just going to let you take the stage and tell everybody, why is version 12 so different from version 11? We've heard, the kind of the explanation that this is AI coded versus version 11, which was 300,000 lines of 300,000 lines of code and lots of neural nets. But tell us your words, how is this different than version 11 and the other versions ever come before?
Yeah, so it's a little earlier than we thought. So it's end to end is always where this was going to go. End to end is a system where the neural network essentially spans the system from the input all the way to the output, and nowhere along the chain of control is there a non-neural network piece of software necessary. So that's what end-to-end means at the inference stage. Inference is what happens in the car when it's operating. There's another way end-to-end gets used, which is describing training. And end-to-end training is how you train. It's the kind of fundamental way that you train an end-to-end system. So if your neural network basically takes all the inputs for the system and then does everything necessary to generate the outputs. And in the case of a car, this is like take the cameras, the sensors, everything the car knows, which is mainly cameras. The cameras completely dominate in the case of FSD. And it does all the processing necessary to generate outputs, which are turning the steering wheel, pressing the brakes, pressing the accelerator. That's what we call end-to-end in the case of a self-driving car, because it's a neural network that runs from one end, the input, all the way to the other end, and it doesn't have any breaks in the middle where something has to be modified, manipulated, injected by a piece of regular human-written code in order to get the system to function. So the thing that's new about V12 is they're doing end-to-end, right? It's end-to-end inference. That is, in the car, the control, and this is for the control system, right? Because we know that there's more to the neural network in the car that in V12 that got demonstrated to us than just the end-to-end system. Elon told us that the cameras come in, neural network processes it, and then the outputs are steering and brakes. But we also know, because there's the mind of car display that we see, that somewhere along that chain, it's also making a vector space, because the vector space is what generates the inputs to that display. So there's still a vector space in there. And in fact, it's almost certain that the way that 12 is being built now is it's being built on top of much of what was developed on 11, or 10 or whatnot. So autopilot has always had a certain amount of neural network in it. It's always had neural network at the front end for perception, because you just can't do perception. You can't take what comes in from cameras and turn it into a useful understanding of the world that you can drive with without neural networks to do a really significant amount of that kind of stuff. So early versions of autopilot and the first versions of FSD were the neural networks were basically taking what's coming in from the cameras and turning that into something that someone could write a piece of software to control the car with. So, for instance, it might be a list of like, what kind of road am I on? Where are the stripes? Where are the stop lines? Where are the signs? What is the speed limit? Like, the neural network looks at the environment and then it generates a whole bunch of bits of data out. And then a regular human written piece of code decides what to do, makes a plan on the basis of what the current situation is, and then another human written piece of code like takes that plan and turns the steering wheels and hits the gas and brakes in order to get the car to actually do that thing. So over time, what happens? You can't. For various reasons, which we can get into later, it's actually really hard to start out end to end. So you kind of get there incrementally. Tesla has gotten there incrementally. In the beginning, they just had the neural networks at the front of the system, and most of the middle and all the stuff at the end was human written code. Over time, they've added more neural networks as helpers for the intermediate stuff, for the planner and for the control system. And then in this last year, we heard that they were doing neural networks for control, which was kind of surprising because neural control itself can be done pretty well. Just with human written code. And which is not to say that neural networks can't do it better. It's just that of all the problems they have, it didn't seem like control was one of the ones that really desperately needed attention to. The stuff in the middle, planning, was kind of on V11, it's kind of a combination. And on V10, it was also a combination of neural networks. The planning itself is mostly done by human written code, but there's some parts of the planning process where it's really useful to have a neural network to help you out with stuff. For instance, at AI Day 2, we saw that evaluation where you've got a car coming, you want to turn left, and there's a pedestrian crossing at the same time. So you have to make a bunch of judgment calls and you have to make a bunch of future predictions. What's the pedestrian going to do? How soon is that car going to get here? Might he change lanes? Should I go now? Should I wait for the pedestrian? Should I wait for the pedestrian and the car? Like, what's the best course of action? So on 11 and in 10, on 11 in particular, that decision is made by a combination of networks. There's some things that are difficult for regular software to quickly process and give you a good answer on because essentially searching a space of possibilities can be really slow. And neural networks can take a big space of possibilities and they can turn it into a little space of possibilities. And then your regular human written code can basically take that and make an action on it. So that example of the pedestrian, the car, and the ego vehicle wanting to turn left is an example of that. And over time, what's happened is Tesla has added more and more of these helper neural networks to the planning stage. And it seemed like it was going to keep going that way. But now, we know from this CNBC excerpt from the Isaacson book yesterday that about a year ago, Tesla found that they had a way, they could just take the planner and they could pull the planner out, put a neural network planner in, and they could put in a neural network planner that was trained to mimic human beings. Like there are lots of different ways you could build a neural network planner. There are lots of different ways that you could train a neural network planner. So this is a particular one. Somebody at Tesla had the idea, hey, let's try this. Now, of course, this is not like nobody ever had this idea before, but it's been really hard to make it work in the real world. So somebody at Tesla decided to give this a shot on top of what they already had. They have this perception system already, which is pretty mature. They've got all these other building blocks that they've kind of sorted out. And he asked the question, well, what if we put a planner in to replace all of this code that we're writing right now? And we just train the planner to imitate what good human drivers do. Now, of course, in order to do that, you got to build that thing, and then you got to go out and capture a bunch of good human drivers examples, where the example is, it's clips of 10 seconds, 30 seconds of driving and what the human did. And the way you capture that data is the car drives. It captures all of the stuff it sees in the cameras, and it pays attention to what the driver does in this situation. And so you build this database of examples, and then you try to train this neural network to basically tell you what would a human do in this situation. Now, they're not, because they've already solved the vision part, mostly. They already had that in 11. They already had that in 10. They had already been working on the control problem. Once you put the planner in there, now you got the whole shebang. You can go from the input all the way to the output, and you're in neural networks, nothing but nets all the way from one end to the other. So once you've got a complete neural network system, now you can do an additional trick. Like you could train the planner to mimic what humans are doing based on just the planner doing that thing. But once you've got the whole neural network at the end, now you can actually go further without, you can just basically, because you can back propagate, you can train the whole system as a single unit. So you can start out by training the vision system, and then you can do a certain amount of training on the planner, a certain amount of training on the controller. At that point, you bolt it all together and you fine tune it by giving it lots of further examples, where the examples you're giving it is just video and just what the human did with the controls in that situation. So now you've sort of got this virtuous cycle that you've built all the building blocks. You've got all the stuff basically working. You know the architecture that you need to have at each stage of this pipeline. And now you've gotten yourself to a point where the system works well enough that you can fine tune it by just getting additional examples. And it opens the possibility of further development from this point forward being done in a different manner, which is advantageous in various ways. And so I think it is a significant divergence from what they've done. It's very likely a significant benefit because you wouldn't do it. There's a lot more learning curve that they're going to have to get through. There's all this additional stuff that they're going to have to build now that they didn't have to have before. They're going to have to develop these new procedures. They have to build this new collection infrastructure because they have to, mention that in the next couple of weeks, they'll be pushing out a shadow mode version of this, which will probably run on pretty much all of the FSD cars that are out there so that it can use all of the data from all of the drivers out there. Whenever they're driving in manually, it can gather clips from them. And those can be curated, filtered, added to the database, the parts of them that are useful. And then that can also go into the training data. So they've got to do all this additional work because in a sense, they've kind of changed a pretty fundamental component of what they're doing. But there are a lot of benefits to doing it this way, and I mean, we can talk about what the benefits are. There are a whole bunch of them. There are costs because obviously it's a change. Now, I think it was predictable that at some point they were going to end up here. I didn't think we were going to see it for a while, and it's exciting that they found a way to do this part of the pipe to basically do the planner end to end. And that was the final piece they needed to build the whole system end to end. So this is all great news. I'm excited to see it. I was quite impressed with the performance that they had. So that's my initial takeaway from watching the Elon video.
Okay, fantastic. So there we go. All right, so that's fantastic. Thank you for that. That very nicely explained that this is absolutely brand new, but it needed to be built on the existing as they iterated to software 2.0. Now they're having the end-to-end solution. So I'm going to play a few clips, a very short clip from Elon and Ashok's Drive, where they talk about nothing but net, as you mentioned. And then I do have a question about how many video clips do they need, and then can competitors do that? So let's watch this clip here.
Once again, there is no line of code that says stop at a stop sign or wait for another car.
Who came first or whatever.
Or who came, does not wait X number of seconds, nothing like that. Nothing. This is all nets, baby. Nothing but nets.
Okay, so that's exactly what you just explained. Mm-hmm. So the next thing I want to ask you, though, is this recent tweet that Elon just actually mentioned earlier, just this morning. The fact that they need to have, it says here, there we go. So this is part of the book that Isaacson wrote. He said that Elon Musk latched on a key fact that the team had discovered. The neural network did not work well until it had been trained on at least 1 million video clips. This gave Tesla a big advantage over other car and AI companies. It had a fleet of almost 2 million Teslas around the world, collecting video clips every day. We're uniquely positioned to do this. And then this morning, Elon tweeted out saying that a long tail of training data, reality has a vast number of weird edge cases, is required to solve self-driving well. And he added, and a crazy amount of training compute, which is currently currently our primary constraint. Okay, so the question that people have been asking, of course, is, he's mentioned that you need 1 million video clips. Basically, at this point, the new version 12 is basically trained by video clips. You show it what humans do, and it does that. So what I'm confused with is that, do you need a million video clips for each edge case, or that dichotomy of how much do you really need for the training data?
Well, okay, so from Isaac's, when you read Isaacson's stuff, keep in mind Isaacson's not technical, and so he will frequently paraphrase things, a technical comment, in a way which it could be misleading. It could be misleading because it's a generalization. So I think probably what he saw occurring was that, I described this narrative where they decide that they're going to try replacing the planner with a neural network, so then they can end-to-end thing. And once they decide that they're going to try that in a particular manner, they have to go out and collect a bunch of data. Well, so you start collecting data, right? Now, this data, it's not like the data that they've already got, because they want specific examples of a human being driving a scenario where they've captured all the data at the photon level, at the lowest level that they want to train from, and exactly what the driver did in that situation. So up until now, that hasn't been a focus of what FSD was what the data engine was gathering data to train. I mean, if you're not training end to end, then you're not selecting for clips that are dealing with the system end to end. You're for instance, anytime a car, if the thing you're trying to train a neural network to do is tell if a car at an intersection is stopped at the stop sign or just happens to be parked there, you need lots of examples of cars at stop signs, and lots of examples of cars parked near stop signs. And then you train the neural network specifically to discriminate between those two. And those, in that case, you don't really care what the driver's doing. You're just capturing the video. So up until now, a large, like virtually all of the data that has been captured has been focused on this kind of training the perception system, training higher level perceptions to discriminate things, or training sequences of how agents moved at intersections or something to be able to make predictions or something like that. But they weren't trying to train from the cameras in to the output, so they wouldn't have the right database to do that. So they have to collect that database. So now they're collecting the data, right? And they put they collect and curate and then train it on 10,000 clips, 50,000 clips, 100,000 clips, and all the time they're doing this, the team is like, it still doesn't work, or something. And then what they notice is, as they train it on more and more data, that around 1 million clips, it's drivable now. Like, of all the millions of little things that you have to do to drive a car in a way that's not terrible, they managed to cover the overwhelming majority of those in, say, 1 million clips or something like that. Like, it started not being terrible. So at around 1 million clips, they started going, yeah, this is going to work. But you don't stop there, right? Because the more clips you train it on, especially by curating the clips specifically to focus on things it's not doing well now, you give it more data, more good examples of the things that it's not doing well at a particular point in time, and then it gets better at those particular things. So, this, and then Elon's further comment, like, it takes a lot of training data to do this kind of stuff, because you're trying to pull examples of good behavior from the real world in a super varied circumstances. So you need lots of examples. You can't train it on infinite stuff. They don't have infinite compute. They don't have infinite storage. They don't have the bandwidth to pull everything from all the cars driving, right? You have to pick and choose in order to do this. And some mixes of data will give you better results than others do. So they spend time understanding what kinds of clips work better. What if they had it would help make the system better, and then ask for more of those or go searching for more of those. So the process now is figure out what the system isn't doing well really right now, and this is back to Karpathy's data engine, except instead of gathering just perception examples, now they're looking for end-to-end training examples, because in particular, the thing that they need to train now that they haven't had to train up until now is the part that goes all the way to the user controls. So they want these complicated situations, and what did the human do in that situation, so that they can train the system to do that. Does that answer it?
Absolutely. Yeah, that's what I want to do. So I want to show you another clip, and it's a longer one, but tell me when to stop. It's 3.5 minutes long. But when you said that that you actually needed the labelers because I think I heard Ashok say that they need to now label which drivers did it correctly. They need to parse out. It's not just the millions of clips. It's millions of clips of good drivers. I think Elon referred to it as 5-star Uber drivers.
Yeah. So just to preface that, so what labelers used to do is you would take a picture, and there were all these things that you were training the car to like know about: stop signs and dogs and poles and gates across the road. And so a labeler would take one of those, and you had to like draw boxes around and put, tag every single thing in it. That's what the labeler did. They labeled all the objects in the images. Later, when they went to training from video, so they were training in 3D for the top down and whatnot. Now the labelers, they had this auto labeler that would like take in a whole bunch of video, create a 3D scene, tentatively label all the fire hydrants and trees and stuff like that. And then the labeler's job was to go in and verify all those labels were the right thing, to quality check it and to make adjustments to what was going on. So now the labelers, they still have labelers, but in this case, what the labelers do is they're curating the data set. I mean, you can still call them labelers. They're labeling, this is a worthy data sample and that is not worthy. So they're applying a label, but you only use the good ones, right? So in a sense, they're just curating the data set that you want to train on now. Or they might be, another aspect of curation is to decide whether a particular, like for instance, say, the failure that we saw, or that we will see later on, is the vehicle failed to correctly identify which light in an intersection was the light that was relevant to its lane, right? So a thing that the team might want to do is it might want to go to the labelers and say, hey, we need more examples of where it's kind of a confusing light, but the driver makes the right choice. It can be confusing in lots of ways. There can be different backdrops. It can be a complicated intersection. It could be that it's got like an unusual light configuration that's rare. All kinds of things, right? And so labelers need to sort of look at where the failures are, and then go through all the stuff that they have to say, this is a good one, and that's a good one, and these probably won't help, and so on, to help put the ones in the database for training that are going to help the system get better.
Right. And this is the example where you can't just do end-to-end by itself. You actually need it to all the work that you did previously.
Yeah, it's not like a garbage truck and you just back up and dump data into it and it gets better, right? The quality really matters. And I think somewhere in this thing, Ashok comments that it's not just any data. We want quality data. We want data that addresses the weaknesses the system has right now.
Okay. So I'm going to actually play the intervention first, which is a shorter one. Then we'll go to the explanation of.
We're driving around. Basically rush hour. Intervention. Sorry. Okay. So that's our first intervention.
Question in the traffic lights.
That's right.
Oversample traffic lights. Yeah.
Okay. That's why we don't release it to the public yet. So an intervention at this traffic light. That's the first intervention in the whole drive. So for that intervention that we just had, the solution is essentially to feed the network a bunch more video of traffic lights. So that was a controlled left controlled left turn, where there was a green light for the left turn, but not a green light to go straight. And so we'll feed it a bunch of video of controlled left turns, and then it'll work.
So what do you think, James?
Actually, one of the things I find, first of all, you're going to have those kind of failures, right? It's like until the system is done, you're going to have failures. And so, system development for them from this point out is like finding the worst ones and getting those fixed, finding the next batch of worst ones, getting those fixed, and so on. They'll start working their way down this chain. As they do that, you asked the question earlier, like, do you need 1 million clips for every, individual and the, edge case? The answer is no, because every clip contains a whole lot of information about a whole lot of different things. So, I mean, you want to add clips that contain a particular little thing that you want the system to see, but every single clip also contains all kinds of other stuff. And so the system becomes more and more trained on that kind of thing. So, when the first 1 million clips or whatever, they didn't necessarily have to do a ton of curation on those, because in the beginning, almost anything is useful from planning, and as the system gets better, you kind of want to be more selective about the stuff that you add in. But the system is always learning an enormous number of things from every single clip that's in there. Like every clip reinforces, you know, thousands, millions of little pieces of knowledge the system has about what trade-offs it should make, what patterns are here, what patterns aren't, you know, what patterns interact, what are worth responding to, what are ignoring. Like it's got all this stuff that it's got to learn. So so in the beginning, learning is kind of easy, you know, because you don't know anything, right? So almost anything is better than that. But the better you get, the more it's kind of curated you want to be, the more selective you want to be about what you bother to train yourself on, because of all the stuff in the world, there you might be in a place where a minority actually is rich in the thing. It's kind of like, you know, lithium mines. Lithium is available anywhere, but you get good ore for digging up your, you know, we don't drill for oil any place in the world. You know, you drill where there's the most oil, and data at some point is like that too. That you want to be selecting the data that's richest in the stuff that you think that the system needs to learn. So it gets harder, and you need to put more work into curating. Like you become more sensitive to quality the farther you go down the path of like the march of nines, essentially dealing with all the edge cases. And it's going to be a long time before they've nailed all of those, right? Like how fast will they close them off? Hopefully fast. This is an empirical thing. They're going to have to try it and see for the most part. We don't have first principles theories in machine learning that let you say, you know, with confidence, if I had this and this if I had this data with this network, I will get these results. It's an empirical science at this point. You build stuff, you look for trends, you try to figure out what's helping and what's not helping. Then you do more of the good stuff and less of the bad stuff, and hopefully things get better. But you kind of have to walk down that road to see what it is. So we're going to see failures for sure. And
Okay.
now, one of the things I thought was interesting, like seeing this again, was this is not a technical thing, but Elon's kind of response and Ashok's response to the failure of what was going on. There was like this to my ear, a very notable change in the character, the tone of the way that they were talking about stuff. My read is they didn't expect it to fail. Like this is the Cybertruck, you know, breaking the window moment. You know, they went in the back room, they tested it 4 or 5 times. Great, yeah, let's demo this to people, and then they got a failure that they didn't expect. They're a little bit taken aback. You know, they recover and they talk about it and that kind of stuff. So, so from that, I take that to me that's great because it means that probably most of the drives are better than this, right? It's like they didn't go out and do the demo tent. Like one of the problems that you can get with self-driving cars, right? That is that, you know, people can drive, you can have 10 terrible drives and the only clip you share is the one that went well, right? And I think what we got this time was probably kind of the opposite. They drove it 10 times, it was great. And then they got one that didn't go so well, right? So it's probably better than this even. So
well, he said that they haven't actually tested that specific drive necessarily. This was all ad hoc kind of thing.
And I think Ashok said at some point that was a regression in the Model S, or like listening through it, I got the impression that there was a comment from one of the people in the car that like, "Ooh, yeah, that thing's back." You know, we thought we had it fixed, right? Kind of thing.
Interesting. I'm going to play this longer clip. It's about 3.5 minutes long, but stop it if you want to make a comment. And they talk about how it's trained, because I think that Ashok actually says, well, one option is you actually feed it more video of how to address that particular issue, and then they label it, and then they kind of they dial in the weighting for that particular human action to that specific scenario or scene. But then Ashok says something like, oh, you know, we can actually just do shadow mode. We can look at the shadow mode stuff and adjust it from there. But
yeah, so shadow mode is a way for them to, 6 months ago, we started seeing these advertisements for FSD drivers in various places, right? People were tweeting out the things and Tesla was advertising. And now I think in retrospect, what we can say is, oh, they were hiring people to drive FSD 12. And later they mentioned, we've got people driving FSD 12 in, you know,
every country.
Thailand and Australia and all of all these places. So FSD, when they first had 12 working, when they put the first million clips in and it could drive without like running into trees and stuff like that, they were like, hey, this has promise. But you don't give it to customers at that point, right? You still need more training data, but you can't give it to customers. What we would like to do is run it in shadow mode on customer cars and use the 400,000 cars out there to gather data. So if you need more stop signs, you send a request out to the fleet, hey, capture clips of people driving through intersections that look like this or that have these characteristics. And then you get a flood of them back from the fleet. And then the labelers can go, no, 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 yes, no, yes, no, and then feed them in. And that's the data engine turning, right? You ask for stuff you need, you filter it to make sure it's the right stuff. Then you put it in the pipe, you train, and then it gets better. You push that out to the fleet, and then you do it again, right? That's Carpathy's data engine. So having a shadow mode version. And Ashok, if I remember right, he said, yeah, inside 2 weeks, they expect to push a shadow mode version of FSD 12 out to some cars, maybe all the cars in the fleet will get this. And suddenly they'll really start getting a lot more data. But in the meantime, you need to be putting this wonky software on a bunch of cars. So you want to pay people to drive it in particular locations. Like you can't, because you don't have 400,000 people just gathering stuff and you can pick and choose what you want because they're just randomly going to drive by this a certain number of times every single day. You need to have a bunch of people where you can say, go drive this and do that, or go drive this and do that. So they're people who work for you. And that's probably what, these FSD drivers that we've been hearing about have been doing over the last 6 months, is gathering this data, feeding it in so that they can start getting the pump primed for getting this thing going. Then once they get it to where they can push it out to the fleet, now they can really get a lot of data in. And of course, the other thing they need is a thing that was in one of the tweets that you had highlighted before is Elon basically saying it's going to take a lot of data. There's so many edge cases, right? We really got to get a lot of this stuff. Training from video is really compute intensive, so you need a lot of compute, and they're compute constrained right now. But he also he replied to a tweet that I had said to somebody about talking about compute constraints and how much the stuff was going up. And he replied and said, yeah, I think that we're going to be over this compute constraint relatively soon, or something along those lines of like, we're compute constrained right now, but it's going to get better pretty soon. So like this year, they're going to go up 20x or something like that. And as soon as they can get ahead of how fast they can bring the data in and get it processed, then they're no longer compute limited. Now maybe they're data limited at that point, or maybe they become, if they have to do a lot of labeling, maybe it's labeling limited. But right now, the biggest thing that's preventing them from making more rapid progress as of just today, this week, this month, is they need more computers. And they've got a 10,000 node H100 cluster coming online. It'll take them a few months to get it running, and that probably will deal with their needs for a few months, right? So I think that's how I read that.
Okay, good. You know what? I'm not going to play the clip anymore. I think you've actually really covered it well. I'd love you to share your slides, but before we do that, I need to ask you the question because this is the one that everybody's asking, and there's a lot of confusion out there. People think that competitors can copy, and that this is, Tesla might be the first, but some people think in 2 years, competitors will copy. Now, we've heard Elon continue to say you need three things, right? You need billions of miles of videos. You need to have a supercomputer, which costs billions of dollars to spend. And you need to have the neural nets and smart people to be able to write these things. And so can you just explain right off the bat, what is your expectation for competitors and who might be able to do this? And then, like we just said, can anybody just get the million, videos that they need to be able to do this as well?
So different people are taking different approaches to trying to solve this problem. Waymo's got their approach. Comma has a different approach. Mobileye has an approach. Tesla's got their approach. I like Tesla's approach. I always like Tesla's approach to this. So I'm probably a little bit biased in this thing. To do Tesla's approach, you need Tesla's infrastructure. And one of the things that's critical to their infrastructure is you need those cars. It's not sufficient to just gather data from the cars. You need, and this was true before, it's doubly true now, but you not only do you need a million cars out there, a really large population of cars driving this stuff. And just to be clear, it's not the 400,000 FSD cars that are important one. That all of the, there's 4 million Teslas out there driving around that have the hardware that they can gather data with this stuff. Because for this kind of stuff, and for a lot of the regular FSD stuff as well, the FSD 11, FSD 10 perception and whatnot, any car that's instrumented, you can gather data from. It doesn't have to be driving on FSD. As we were mentioning before, the quality of the data really matters. So you can't just hoover up, I mean, for instance, say that you had a million cars out there and they were just driving around recording stuff, but they didn't have the capacity to run FSD. You just had cameras on cars and you just have all this data. Well, first of all, you can't ingest all that data. You can't store all that data. Video is really big. It takes insane amounts of storage. I think, as Elon had commented today, just storing the stuff that they want to store, the stuff that's actually useful, takes mind-boggling amounts of storage. And if you're just going to store everything that a lot of cars come from, it's not doable. You can't do that. There's not enough storage. There's not enough bandwidth. That's not a practical approach to trying to solve this problem. Tesla's approach was to get filters out there. The cars are smart. You can tell the cars what you want, and they go find just that stuff, and they send it to you. So you don't get, if a car drives for an hour, you don't get an hour of video from all 8 cameras. You get 10 seconds of video of the one thing that you really wanted to see, that you needed to add to your data. So that's a really critical component of this. The fleet is a search engine. It's not a tape recorder, right? It's not just recording stuff. Okay, so there are other ways that you can approach the self-driving problem, like Waymo and Cruise. They have a different MO, and there are other companies that are doing it differently. Wave is doing interesting stuff. Comma AI is doing stuff. Nobody knows. It's not possible to know what is going to work in this stuff until you get out there, do it, and you prove that it works. You work through all the engineering problems and you get it solved. So, will Waymo and Cruise, will Comma continue to get better? I think all these people will continue to get better. How soon will they solve the problem? Even they don't know. Nobody really knows. We look at the progress. We look at how close they're getting to a solution. Waymo and Cruise have a kind of solution right now, a kind of solution for a kind of market that they're interested in pursuing. And so they're going to have a certain level of success. If when we talk about a competitor, like another OEM being able to do what Tesla is doing right now, the systems that we have seen out there in the world that are getting some amount of traction are, there's the Christmas tree approach where you put a zillion sensors and you have a trunk full of computers and you put a ton of money into every single vehicle, like the Waymo Cruise approach right now. That's getting a certain amount of traction. I don't see Ford doing that with all their F-150s, right? If Mobileye is doing something, I'm not really paying attention to it. I don't know how much traction it's getting. It doesn't we'll see how they do with this stuff, but I don't think they're anywhere near where Tesla is right now. And I don't think the infrastructure they've put in place or the compute they have in the vehicles is capable of doing that. They're going to have to come up with a different way to do it, and they're going to have to prove it. It's a research project. It's not a turn the crank thing. So if someone's asking a question, well, how soon after Tesla does what they're doing, will somebody else just do what they did? Okay. How long will it take a competitor to put 4 million instrumented vehicles on the road and then run them for 2 years to gather all the data and then train the neural network? Even if you knew everything Tesla was doing, even if they published the source code and shared what they were doing, a competitor's got to build a fleet of vehicles. They got to get them out there. They got to run them for years because they got to turn the data engine crank to get the thing going. And then at the end of that, then they get results that Tesla's doing. Now, it might be a little faster, 3 years from now, 5 years from now. Maybe the computers are faster and that kind of stuff. But, how long does it take to build 4 million cars or 1 million cars and put all the instrumentation on them out there? That's not something that happens in a year, right? That's probably not something that happens in 3 or 4 years, given the build rates at a lot of the competitors. So the idea that someone is going to see what Tesla did and then they're going to go do it a year later, that's not going to happen. Something else could happen. It's certainly possible. I don't think it's going to happen because I don't see any other players that are capable of putting a system in an OEM vehicle, a privately owned vehicle, and putting it out there. I don't see any of them building the infrastructure necessary to close the gap in less than I don't know, 3 years, 5 years, something like that. I mean, I would say that that would kind of be the minimum. And I'd be surprised if somebody did it 5 years after Tesla did, but it'll depend on how the technology moves. The tech moves really fast every year, and surprising things happen. Tesla adapts to these surprises. Everybody else adapts to the surprises, and some of the surprises they may, they may open the gap with Tesla, and some of them might close the gap. It's hard to say.
Okay. Yeah, I don't want to belabor the point, but there's people that are saying, hey, have you seen those videos coming out from China? These cars are already driving in a city. They're able to kind of maneuver through all the pedestrians and able to start and stop. Cruise is already in 7 cities, expanding to 8, and then Waymo's in 3. Anyways, just the thinking that that's already SA level 3 versus, Tesla's stuck at level 2. I don't want to spend too much time on this, but
there are
just
lots
a quick
of,
answer to that one.
it's complicated, right? We're not in a situation where, where everybody's playing the same game and there's a very clear, finish line. And once you cross that finish line, number 2 is the second guy to cross the finish line, or, different people are playing different games. There's different ways to approach it. It's a huge market. My sense of things is like, even if Tesla had a competitor, even if there were other people doing it, it's not really a problem because competitors don't start stealing business from each other until you saturate the market. And the TAM for this market, the number of robotaxis that you can put into the market vastly exceeds the number of cars that can be built by all of the manufacturers in the world, in less than like a 5 or 10 year frame. So like there's virtually no scenario in which people could be competing with each other within like 5 years or a decade, because you just can't saturate the market in that window of time. I think, the fascination people have with the horse race associated with this is misplaced. I mean, it might be fun to talk about, but it's not materially relevant to the fortunes of these companies, right? If a company, like, for instance, if there's a dedicated robotaxi player in the space and investors lose confidence in them because they're perceived to be behind, okay, well, that will have a material impact on their fortunes. But a material impact in terms of like a competitor stealing your business, like that's just not going to happen for a really, really long time. So talking about, how far ahead is Tesla versus Mobileye, I think is just a silly conversation. I mean, it's interesting to compare the technologies, and you do get insight and that kind of stuff. But to talk about how, one of them is going to succeed or fail if the other one succeeds first, I don't see a lot of, reason to believe that is likely what's going on. It will be really interesting to see what number 2 does. My Mobileye's got vehicles at scale out there. They're completely different from Tesla's vehicles. They gather completely different data. They have different infrastructure. Mobileye's business model is Mobileye doesn't sell cars, right? They sell ADAS systems to other OEMs. Will the ADAS market continue to exist after FSD is out there driving in robotaxis? Yes, it will. It has to, because Tesla can't make enough cars to supply the world's needs. There are going to be other cars. There will be demand for ADAS. Mobileye might sell a whole lot of those, and they might be really successful in their space. Even if they don't have FSD, they'll probably get closer. Like once there's an existence proof for FSD, this is one of those things like, not a lot of people were building airplanes before the Wright brothers demonstrated that like it was a thing. And then a few years later, like, there were zillions of airplane companies. Like once you have an existence proof, like people really pile in, and a lot of money flows to everybody in the space, right? I mean, before SpaceX started landing rockets and demonstrating that there were no rocket companies, right? Now they're like 50, right? Everybody's in the rocket company business. So, people could do really well in this business just because Tesla demonstrates that it's possible. Now, long run, who succeeds? Well, the person who succeeds in my mind, long run, though, that you get to scale, you get your costs down, you satisfy, you keep turning the crank, you keep making your product better and better and better. You get more and more of them out there. You develop relationships with customers. You make a lot of people happy. You get the good brand and that kind of stuff. And over years, that turns into enduring success and a real moat, because there's not transportation is a commodity business. Right. It's just going to be, I mean, Tesla could do the iPhone thing where, we're only going to sell the 10% of the most profitable phones and everybody else can fight over the no money left in the rest of the market. that could happen. And Tesla might end up selling a minority of the vehicles and making all the profit in the industry. In that sense, they might not be commoditized, but I don't think they will, because their mission is to bring this technology to as many people as possible, because people using the technology makes the world a better place. You want as many people. The goal isn't to make as much money with the least amount of effort. The goal is change the world. Let's make the world better. And if you want to do that, you want your impact to be as big as possible. And that's why, they're going to make a $15,000 car. Give it time. You can make $15,000 compelling electric vehicles. It's going to take a while to get there, and there will be $15,000 Teslas. They will not do the Apple iPhone thing where they're just going to park at the top of the market. And the same thing with FSD. I think once they've got FSD out there and it's a good enough cash engine that it can feed itself, that it's generating the cash it needs to continue to grow in a healthy way, they'll push the price down, just like they're doing with the cars. You push the price down as far as you can to maximize the growth so that you can feed that engine. And at the tail end of that, like if you succeed at all that kind of stuff, you own the market, right? You won because you supplied all the stuff to all the people.
Hey there, thank you for joining me. If you can, please consider supporting this channel so I can keep it going. It's a lot of work arranging all these amazing interviews. One of the easiest ways is just to click that join button and become a member of the channel. Thank you very much, and let's get brighter. Okay, yeah, no, thank you. So there's a couple things I would just want to highlight, then move on, which is what you said was, this isn't like a technology that anybody can just copy and roll out within 2 years. So those people who think that after Tesla rolls this out, 2 years later, it's going to become a commodity, every car will have this, it's going to take many years. And secondly, the approach that Tesla has, which is very different than Apple, they're willing to license. And so very likely Tesla will still have tremendous outsized gains in terms of market share. And like you said, it doesn't even matter at this point. It's going to be many, many years before you can get that many cars out there that can do robotaxi enabled. There won't be competitive market forces for, maybe 10 years, 5 to 10 years, not in just a couple of years. And so that logic is
just
followed.
To be clear, there are right now, based on what we know the technology can do, the technical hurdles to doing what Tesla is doing, they're very high. It is not beyond the realm of possibility that there could be a breakthrough, and this could all get a lot easier in 2 years. Like that is possible. It is not a zero chance of doing that. But nobody, like, that's going to be a bolt from the blue. Like, you can't predict that. So if anybody's saying, well, that's going to happen, I'm like, okay,
Right.
We'll
You're
see.
betting on something. Okay, so I know you prepared some slides. Can we please see those slides? Because I really want you to explain better how FSD version 12 works. Can you share your screen for me so I can share your slide? Because I just think the simplicity is important for us to explain what's actually happening a little bit better.
Okay, so this is a group of slides I put together. It was just to try to, let's see if that's up, just to try to illustrate, to quickly walk through, why is FSD, why is 12 different than earlier generations? So here's 12, right? 12 has, the stuff in the red labeled box is the neural net. The green labeled box, this is human labeled code. This is human written code. So right now in V12, the way we see it, this is very simplified, incidentally. This is nowhere near comprehensive. I'm just trying to convey a point. Okay, so you've got a neural network. It's got cameras and other sensors. In this case, I call it the IMU, the inertial measurement unit, which is just like, the wheels turning, accelerometers, and that kind of stuff. And then what comes out is the driving controls, like turns the wheel, hits the brakes. If we go back to 10, this is more what the system looked like. The neural networks, the red perception NNs, they generated a whole bunch of stuff that they were calling at the time the bag o' bits, which is just all these, here are the stop signs, here are the street lines, here are the speed signs, and so forth. That goes into the bag o' bits converter, I called it. And that gets turned into vector space, which is like a list of all the stuff around you. And then that goes to the display, just so the human has an idea what the car is seeing, which is code. That's human written code. And then it also goes to other code people were write, the planning code. Now, the planning code has these planning support neural networks that help it. Planning code, there's some things it doesn't know. It doesn't, it needs help processing. So it's got this list of smaller neural networks that help it out. What the planning code produces is a list of goals. So for each one of those goals, it generates a goal, it hands it to the control code. The control code controls the car, and it uses a vehicle dynamics model, which is like, what will the car do if I press the gas right now? It needs some kind of short-term stuff to help it decide, like how fast is fast when you accelerate, or how hard should I hit the brakes and that kind of stuff. So that's what it looked like. Going from 10 to 11, we saw this change, right? So I'm going to flip back to 10 a second. So you see we had the perception NNs, we had the bag of bits converter. When we get to 11, the bag of bits converter, now it's a neural network. So now an interesting thing happens. The perception neural network is now connected directly to the bag of bits converter, which is now a neural network. So these two, they effectively become a single neural network. If you have two neural networks and you bolt them together and there's nothing in between them, you can just treat them like a single network. So at this point, if you want to, you can start training this thing with cameras in and bag of bits out, and camera in and vector space out instead of camera in and bag of bits out. Here, the neural network is cameras in, the perception neural network is cameras in and bag of bits out. So when you want to train that neural network, you have this database that's cameras to bag of bits. When you get to 11, now you've essentially, we've seen a step here where the neural network, the code version, software version 2 has grown a little. And similarly, the other stuff changed a little, but in V11, instead of having a single step planner, we got a multi-step planner, so it can plan multiple steps ahead. It has more new neural networks to help with the multi-step planning. You still have the display code, still have the control code, but now they're starting, instead of having a vehicle dynamics model that's all in code, they've got neural networks basically doing the vehicle dynamics thing. So what we've seen going from 10 to 11 is you get more neural networks, but it's not one neural network. It's not this. It's not a neural network with just some display code on the side. So we're kind of creeping up, having the neural network do more and more of this stuff. Now, this is what's all running in the car. All of these diagrams are basically talking about what's running inside the car. If we talk about how this thing gets trained, well, in version 10, you have your perception neural network, you have your training code. Now, this is running in the data center. This isn't in the car. The training all happens at Tesla's data center. The neural network is there, and the way that it gets trained is this training code has, to the right of it, a giant database of examples that it's going to train with. And it takes an example, feeds the cameras for that example into the neural network, gets the bag of bits out, sees the degree to which that is correct. It's never totally right, because the space of possibilities is just too large. It's not a question of whether you're wrong, it's just how wrong are you? And then depending on how wrong it is, the training network will adjust the weights. Similarly, the planning support network, this is a completely separate network in V10, right? But it gets trained the same way, but with a different database, right? Because it's performing a different function. But it's a neural network, and this is, it's a standalone neural network. It gets trained standalone this way. When you're doing end-to-end training, it looks more like this. Now, there's a part of the training for V12, which is end-to-end. In this case, the neural network has all these different things that are all absorbed into it: low level, mid level, the bag of bits, the vector space, the planner, and the vehicle control. They're all one big neural network. So when you get to this stage, you can train it by basically putting cameras in, looking at the vehicle controls that come out, determining how wrong that is, and then adjusting the weights. So when you train this way, your giant database is camera and control examples. It's like, what did the human do when the cameras saw this? Similarly, but that's not the only way that you can do this kind of training. You can also train all of these sub pieces by themselves. And up until now, this is what we were seeing with all the little blocks. Well, when Tesla makes the transition to 12, a lot of the perception stack is almost certainly highly derivative of the perception stack that they had in V11. And they've still got all of that training infrastructure. And what that training infrastructure can do, and all of those training databases, is you can bootstrap each of these individual pieces. So you want to train end-to-end, but training end-to-end is really expensive and time-consuming. So the first thing you do, when you've got your totally, virgin, never used before neural networks that are completely empty, is initially you do all your training at this kind of subsystem level to kind of get them going so that they get to a certain level of functionality. You can also train them in blocks. You don't have to train them as each individual block. You can say, take, for instance, the vector space maker and the multi-step planner. You could make them a single block, and you could train them as a pair, because any two neural networks that butt up against one another can be treated as a single network and trained that way. So you have this training which is now heterogeneous. You can train submodules, you can train them in combinations, and you can train end to end. And this is what we want to do with the end to end training, right? Is the end-to-end training, it looks really simple. And in a sense, this is kind of what Comma AI does, right? If this is all the training you ever do, the system is kind of easier, because you just have the one neural net, you just have the one training system, you just have the one database. You don't have as many things to do. But the problem with doing it this way, and the challenge, and the reason that most companies that are trying to do this, and many, many organizations have tried to do this, don't get traction, is because of what Andrej Karpathy says, is the training signal is too weak in the beginning. So the training signal, when you've got pictures coming in and controls coming out, is very, very weak. So you need lots of examples in order to get the system to improve. So what Tesla can do, because they did start out doing this, is having their big neural network composed of smaller neural networks, and they can start out training those little networks with things that have strong signals. So you get a lot of learning in those modules. Then, once you've gone about as far as you can that way, you stack them all together, and then you keep getting better by doing the end-to-end training now. So I thought it was worth putting, essentially trying to bring together this idea of what's going on. Tesla hasn't thrown away everything that they had before. V12, it's built on a legacy of the system that they had. They have, in one fell swoop, impressively, they have managed to essentially take out all of the remaining code and glue all the networks together. And once you've done that, now you can train from pictures in to controls out. And that's great. That's really useful. Not the least of which, essentially, whenever you have multiple neural networks, you have to make decisions about what flows between these two neural networks. And the behavior of the neural network is constrained by the decisions that you make there. Once you cross the threshold to just bolting it all together, the neural networks themselves, they can start changing the definition of those interfaces, and they can refine it. And what they do is they use that to solve problems that your engineers were unable to solve. So in a kind of magical way, you get all this stuff bolted together, and the system starts to get better in ways that you weren't able to design it for. It'll solve problems that you were really having a lot of difficulty debugging. But to get to where the end-to-end works, you have to get, it takes a lot of traction. You don't want to do any more training on the weak signal stuff than you have to. You want to do as much strong signal stuff, because you get more learning for the amount of time that your system trains. And that's important right now, because these systems today, they take so long to train that if they took 10 times as long, they'd be impossible. There aren't enough computers, and we don't have enough time to wait to do that kind of stuff. So that's why training is super important. And that's why Tesla really needs a lot more computers at this particular point in time, because at the point they are right now, it really kind of still is impossible. Like, to get to the final V12, they don't have enough computers right now. They need 10x or 100 times as many computers, and they're going to buy 10x or 100 times as many computers so they can do 10x or 100x as much training, and that'll get them there. Or at least it'll get them a lot better than where they are right now. And V12 looks like it's ballpark, V11 class. It probably has a lot more little edge cases that it fails in, but there's so many things that it's already doing well that I think that it bodes really well for how rapid the progress we can expect over the next, say, year is.
Well, thank you for sharing that. That was great, because now you've explained the differences as we go to iterating, and then now we went to the end-to-end. But when I saw your table there, your diagrams, you showed that there's a lot of things that adjusting the weights, for example. It's not just getting as much video as we said. You need to label the good ones. It's not just just throwing the videos and this one to end solves everything. There's a lot of adjusting the weights, because these videos are based on how humans drive. And in one way, that's great, because you're just going to copy humans. And there was one example that Ashok said that, they threw in this car to be able to maneuver through this massive, obstacle course. And at one point, in order to escape out, not hit anything, it had to actually drive through something that it normally shouldn't be driving through, but
Mhm.
it kind of knew how to do that on its own. But it's adjusting the weights because you can't let it drive like the worst humans. You have to drive like the best humans. You want to drive it a certain way in certain locations and certain situations.
Yeah,
So
it's worth pointing
thank you
out,
for
like
that.
the diagrams I showed, they're just like the system in training and the system in the car. It doesn't include the organization itself. It doesn't include like how do you gather this database? How do you filter this database? And it doesn't, and the external engineering things that are also going on around all this kind of stuff. The people training these systems, they're constantly looking at what is working and what is not working and tweaking the process, changing what's in the database, changing the learning rate, changing the amount of data you put in all the various submodules before you combine them, changing the sequence with which you combine. There's just zillions of variables. So there's all this stuff that's going on, which is not in my diagrams, right? The
Yeah,
diagrams are
I
just to sort
understood.
of illustrate architecturally what's changing between 10, 11, 12 in the car and in the data center.
So last question for you though is like let's talk about that. All the things that need to happen in order to actually release a full pure robotaxi network, right? So there's obviously this end-to-end network that knows how to do video in training, knows what to do in certain situations. And they said that the reason why they've hired uh, autopilot drivers and all around the world, every single country, is because you can't just have in California with sunny days. You have to have rainy days. You have to have snowy days. You have to have all these different environments, and that's what they're doing. They're training that as well. But what other things do you need? You need the app. You need the ability to have I think that they even mentioned that what happens if somebody, when they drive up to, I think Elon said this, when you drive up to a parking garage and then you need to press a button to get the ticket out or something. He was
Mhm.
even guessing maybe we need to have a robotic arm to be able to grab that. They said something like when the car, which they showed at the actual V12 live stream, when it arrived at the location that they said, it actually found a parking spot on the street and parked because it knows
Mhm.
it's time to stop, and then they stopped it. And then they were
Because that's
saying
what
how
people do. People don't
would it be
stop in the middle
great?
of the road when they get to their destination.
They don't stop at the middle of the road. They actually park, right? And that's what it did. That's what it did. And it learned it on its own. And then the other thing would be, could it recognize you? So if it's a robotaxi, it needs to know
Yeah.
that you're the one. And then they go, well, if you wanted to, not a requirement, but if you send it its photo, then it'll actually recognize your face and know that you're the person. And then Ashok said also the same thing. Let's say you want to stop at Starbucks. Well, it recognizes Starbucks, logo. It knows where to stop to drop you off there. I mean, there's just so many things. So it's
Mhm.
not just be able to copy the code and letting the car drive. It needs to be able to do all the things for true robotaxi where there's nobody in the car. Can you speak a little bit about that?
There's it, the first taxis that go out are going to be limited, and as they get better, they'll be less limited. You can, if you just have a car that drives itself around, you can cover a lot of cases right now. The doors opening and closing themselves, like that was another thing that came up in that little excerpt. That robotaxi probably needs to be able to close its own doors because it's going to be really common for customers to walk off and either not close the door all the way or not close the door, and that's a dilemma if the car can't close its own doors. The robot arm thing, yeah, we're not going to see that. So they'll put Wi-Fi chips in those things or something. They'll develop a wireless protocol for talking to those boxes, and the boxes will change. So there are going to be these accommodations as the system builds out, and the infrastructure in the world will change a little bit. Drivers will change a little bit. Parking lots will change a little bit as this stuff goes. In the beginning, the car has to do most of the accommodation, and it can't do enough of it. So there are going to be some things that it just doesn't do super well. That said, if the only thing that you can do is the kind of ride share that happens in San Francisco and New York and that kind of stuff, which doesn't really need to do the gate thing, it doesn't really need to deal with weird parking lot entrances and that kind of stuff. Like you can just pick up people and drop them off on the street, and that's a huge market. Like and the reason that matters is because you can build a lot of cars, you can get a lot of value, you can move a lot of people, and you can learn a lot before you have to do stuff like put robot arms on your cars. So you don't have to get too crazy with that stuff. In the long run, a lot of crazy stuff will happen because the market will be as big as the market for all cars. And then you'll see all kinds of crazy stuff. But in the short run, you're going to see a smaller variety of platforms and a smaller variety of business models. and people will be working hard on getting the volumes up and perfecting the software and that kind of stuff. So I think, that's what we're going to see is we will see the technology emerge into the world. It won't be able to do 100% of everything for everybody, but it'll probably be able to do 99% of everything for 99% of the people.
Okay, so let's end with Ashok and Elon. This is what Ashok replied after they finished the version 12 live stream. This end-to-end neural network approach will result in the safest, the most competent, the most comfortable, the most efficient, and overall the best self-driving system ever produced. It's going to be very hard to beat with anything else. The confidence from Ashok. And he continued
that's great to see.
Yeah, and then he continued to say that it took a tremendous amount of high-quality data from the fleet, a very large amount of compute, and a world-class engineering team to get to this point, meaning to say that it's not something that others can just easily copy. And then Elon replied saying, it's super hard to do this. Now, this is the part that I thought was interesting when he said, even when FSD is 2 times as safe as the average human driver, fully unsupervised in all scenarios, then we're going to want to make it 3 times, 4 times, 10 times safer. And so this is just another comment where, okay, so let's say that somebody else can copy this. Let's say it's 2 years. Well, which car would you get into? The one that's 10 times safer or the one that's 2 times safer? They're always going to be in catch-up mode.
Well, the counter to that is like how many people know what the safety records of the airplanes that they fly in are, right? Because there are variations, but most people consider that they're all good enough and they just get in. And the same thing, people who buy cars, they kind of generally don't know if people really cared about buying the safest car, there would be an even longer waiting lines for Teslas, At some point, people consider stuff good enough and they go. And I think the robotaxis will be in the same space. People are leery of stuff they don't have direct experience with and that their friends haven't done, stuff that seems weird and seems new. And robotaxis are definitely weird and new right now. And they're going to be definitely weird and new for a few years after they come out. But they're very rapidly going to normalize. Just like, I remember when cell phones first came out and, you would make fun of a guy walking down the street who had earphones in, right? And I can't wait. In San Francisco, Karen and I, the joke used to be, is he crazy or is he on the phone? Because sometimes you can't tell. He's just talking to himself or what's going on. But it used to be like people were really self-conscious about doing that, right? And it took shockingly little time for the social norm to change, right? Like people just do it all the time now. Like in San Francisco, I walk down the street, 10% of the people I see are talking on the phone to some or some invisible stranger or whatever. And, maybe 10% of those are crazy people walking around San Francisco wishing they had somebody to talk to. I don't know.
Okay. Well, talking about crazy people. So tell me now, you saw V12, you understand what they're doing. We also did a live stream. We think it was a historic kind of a demo that this is happening, but things seem to be heading in the right direction. What is your, how your confidence level? Are you more confident now after knowing that they're working on this than you were, let's say, a year ago when we were still looking at the V11 approach?
There are risks and benefits to making the change of direction. I think on balance, the benefits outweigh the risk. The benefit is that it moves faster now. I think it will, because the constraint that they had on how fast they could move before was more about people and less about computers. And so with this approach, you're shifting it away from the people because the problems that you have are less likely to be something where you need 5 smart guys to go work it really hard for a month and figure out what to do, and then you change your internal processes. A much larger fraction of all the problems that they encounter are going to be get some data, feed it in the computers, turn the crank, boom, right? Like that is the Carpathia's data engine. It could solve a lot of problems, but it couldn't solve all the problems. They still had to, they would still run into things where rather than gather the amount of data that it would take to fix this problem, let's make these changes to the system. Let's add this other neural network that does this, or let's change the way that the heuristics make this kind of decision because it'll work better. And so in order to be able to make those kinds of improvements, you need lots of talented people working really, really hard all the time, right? To do this because you want your organization to be small and tight and you want to get a lot done. And that means everybody has to work really hard. And you only find so many people to do that. So your constraint is people. And their constraint, I think Tesla's constraint has been people for 3 years or something like that. And that's why AI Day 2, right? Because They need more people. They got to get out there. They get the word out. They got people to want to come work. They have particular people that they want, and they want to come and work really, really hard. So that was a huge constraint. And the bigger the system gets, the more cards you have, the more of those people you need. And there's only so many. Your system can only ingest so many. You can only seat so many. Once an organization gets bigger than a certain size, it starts to slow down because communication, partitioning, there's all kinds of things that you bad. If you can shift the dependency to more data, more computers. Well, more data, more computers, we get those anyway. Like every year the computers get faster, every year the computers get cheaper. And especially now with, there's this huge ramp in the power and number of these AI computers that are available. Like it's just absurd how fast this stuff is growing. So you want to shift your model to where that's your constraint, because that's just going to get better. I mean, even if Tesla doesn't get, even if Dojo doesn't succeed, NVIDIA is going to keep making better computers. Tenstorrent's going to make them. There are tons of other people. Google's, they've got a TPU 5. They're going to make a 6 and a 7 and an 8, right? I mean, these resources exist. And if you can make your problem, if you can shift it over to something that's abundant, then that's a big win. And I see V12 as doing that fundamentally. It's like moving the constraints on how fast they can move off of something which is hard to scale and onto something which is easy to scale. So that's really important, right? Now, the downsides are it's new stuff, right? Training end to end, training from video, doing the control stuff. We're gonna see failures that we haven't seen in V11 for quite a while. There are going to be some things that are kind of harder to solve with the V12. Maybe the light is one of those things, right? I mean, back in V10, occasionally it would get the light wrong, or in V9 it would get the light wrong when it was at a light. So, but at the same time, there are compensating things. Many things are easier to fix by just putting more data in, because they don't take introspection. You don't have to debug the system. There's also this benefit that when your failures are failure to mimic a human being, people understand that and they are forgiving. A lot of the complaints you say, a lot of the discomfort people have with using V11 right now is when the car is doing something that makes no sense to them. Like that's a really, you're going down the highway in this 3,000-pound death machine, right? And if it starts doing things you don't understand, it's a very nervous thing. If it does silly things that all the other drivers do, you're much more forgiving of it. Like you have a sense of what's going on. It's not a black box. So there are these risks. There are going to be these costs to making this transition to what they're doing. That said, it's very promising and it has a bunch of benefits that I think people are going to appreciate. So I think that's where we are, right? I'm very hopeful about this. We're not really going to know how it's going until, we see a couple more iterations or we get in our, it's just like everything, right? One of the reasons we know a lot about Tesla is because we all drive the product, right? Tell me how good Mobileye's cutting edge product is. Well, nobody except their engineers has ever seen it, right? Tell me how good Waymo's cutting edge project is. Well, you can only drive it where they want you to drive it. You don't get to, you don't have a bunch of people on edge cases like taking Waymos out to the middle of nowhere and having them run obstacle courses, right? So it's hard to know how good the systems really are. With Tesla, we know, anybody can drive it. And when we get it, then we'll have a much better idea how fast things are going. But I'm pretty optimistic that the rate of progress is going to improve, and that a lot of things that are really annoying are going to go away. And Elon had suggested before that V12 would not be beta, that it's going to be a lot smoother. And having seen the V12 demo, it's a lot easier for me to believe that that's true. It's still got Elon's optimism bolted onto it because, as I said before, it's an empirical field. You know it when you get there, kind of thing. Like there are no guarantees. But I think it's looking good. I'm very pleased.
I am too. I mean, you got Elon optimism, but you also have Ashok optimism. And then you also have just the fact that the shock of seeing how this system, they did not code it on how to do a roundabout, did not code it how to read signs. They didn't code it how long to wait. It's just mimicking what human drivers do. So anyway, thank you so much, James. That was fantastic. Exactly what I hope to do. I'm sure our audience is going to be extremely pleased because you've explained a lot of things in a very simple way, but also pointed out the key things that are important to remember and to point out. So thank you for that. And then, we didn't get into a lot of other topics. I know that some people are going to say, why didn't you ask him about the dojo and supercomputers? Just don't have the time. Maybe next time. Please follow James at Twitter at James Douma, Jimmah. His name there. Hopefully you learned something new, and
I'm
press
really
like,
looking
and
forward to
we'll see
seeing what
that.
happens. I can't wait to get my hands on it.
I can't either.
But it's
But
probably going to be a wait, but we can hope.
well, so shadow mode in 2 weeks, but then Ashok did say in his CVRP presentation in June, he said that he paused for a long time, but then he did say that it could be that this is released to us, the consumers, by the end of the year.
Sure.
So
That
it's
is
now
entirely
September,
within
so
the realm of possibility.
it could happen now. Okay. Thank you, James. Appreciate it. See you later.